Okay guys, so here's our video for the skeletal system. It's going to be probably one of possibly 2 or 3 videos, so this will be our first one. For starts, our skeletal system, it has very specific functions, just like our integumentary system had very specific functions to, of course, protect us, to help protect from UV damage, to help protect from microbes, to help with thermal regulation. That was all integumentary. Well, the bones, or the skeletal system, we say also helps support structurally. It supports our entire body structurally. It also helps with protection from things that could possibly injure our organs. Think about it. Your heart and your lungs is kind of encased in a cage, so to speak, and that's, of course, what we know as our rib cage, our thoracic cavity. And so, you know, our bones help with protecting our vital organs. Our bones are also a site of attachment for our muscles. Of course, we want that to happen because if our muscles were not attached, well, then they would be pretty useless to us. So it's very important that we have an attachment site for them. And then, little common known one, some people actually don't know this, but bones are actually the production site for our blood cells and platelets. So you guys may have heard of it like bone marrow. But it's super important, of course, even with our cardiovascular system and just producing blood cells to begin with. And then, of course, for storage, it stores various things. It could store various minerals that we get, like calcium and things like that. It could store some fat. It could store lots of different types of minerals and other types of molecules for us. So let's just kind of get into the types of bone tissues that we can find. We have 2 types of what we call osseous tissue. And anytime, let me just give you a little hint. Anytime you hear the word osteo or osseous or anything with this osse something in there, that O-S-S-E or O-S-E-O or something like that, that is always going to be referencing something to the skeletal system, something bone related usually. And so our 2 types of osseous tissue, we say number 1 is compact bone. So compact bone is a normal bone that we kind of think of sometimes. If you've ever seen a dog gnawing on a bone, on kind of like the middle part of a bone, that's going to be our compact bone. And it's called compact, okay, because it's very thick. The cells are very tightly packed together in our compact bone. And so it's found in greater amounts, okay, to help support not only the rest of our body and our entire system, but also for protection. The compact helps with that. That's, of course, found in this middle region, as you kind of see on here. And then the other type of tissue we'll find is called spongy bone. Now, spongy bone is exactly what it sounds like. It's spongy. And it's usually found on the ends of our long bones. This is by the picture. It shows a long bone. And it's usually found on the ends. And it's made out of smaller pieces of bone with lots of empty space in there. So that's kind of why it looks like a sponge. So they oftentimes refer to it as a spongy bone. It can also hold some red marrow in there, some red bone marrow. And just in case you didn't know, red bone marrow is actually responsible for the production of our blood cells, our red blood cells, various things like that. When you're in adolescence, okay, which many of you guys have reached that in this class, your red bone marrow, it actually starts to disappear. It disappears from most of all of your bones, except for maybe your ribs, your sternum, your vertebrae, things like that, and the proximal ends of your femur and your humerus. So most of that is actually replaced by something else, which we'll find out in just a minute. So let's talk about just classification of various bone types we might be able to find in our body. The first one, and the one that's probably most common when people think about it, is our long bones. So our long bones are usually longer than they are wide, which is why they're called long bones to begin with. They're mostly made out of compact bone. As you can see, kind of the whole middle region of that bone that is being shown right now, the humerus of the arm, that whole middle region is compact. It's compact bone tissue. So it's mainly made out of compact bone. And again, a good example of these guys are our humerus and our femur. Femur, by the way, is the one that you find in your thighs, in case you were unsure of that. The next one we find, we call it short bones. Very much different, of course, from our long bones. And the short bones are usually kind of cube-shaped. They contain a lot of spongy bone, which is a lot different than what we find with our long bones. Our long bones are mainly made out of compact bone tissue, but our short bones are usually have a lot of spongy bone tissue in it instead. And good examples of these, of course, are some of the carpals within our wrists, some of the tarsals in our ankle and around our foot region. And so you can kind of see the picture that's zoomed up on some of these short bones. The next type we call flat bones. And so flat bones, they are very much flat. And the whole kind of bone types are very intuitive. You've got long, you've got short, now we have flat. And our flat bones, we find them flattened sometimes, we find them curved, they're thinner usually. We'll find them in our sternum, we'll find them in our skull. They are very important, okay? They're actually made out of a combination of both compact and spongy. And like I said, some examples are our skull, our ribs, our sternum, various things like that. Our last one, we're going to call these guys irregular bones, partly because they just don't fit in any other category that we've mentioned so far. They're very irregular in shape. And so a good example of these guys are our vertebrae. Or you could have even seen like some of your pelvic bone that kind of looks like a butterfly sometimes. That's very irregular shaped in comparison to many of the other bones we have in our body. So now that we've kind of got the different types of bones we'll find, there's 4 types, and then we talked about the tissue, we talked about, we have compact, and we have spongy. Let's talk a little bit about the anatomy side of a bone, more particularly a long bone. Okay, so if you look at my picture that I have here, when we're looking at a long bone, we mainly have 3 sections that we want to care about. The middle section we call the diaphysis, and this is the middle shaft of the bone. It's the one that's made out of where most of the compact bone is found. It's right there in the middle. And then we have 2 ends where we find that spongy bone. Now, if you're talking about the end that is closest to your trunk, in this case, if we were talking about femur, it would be the bone the tip of the bone that is closest to your pelvis region, where it kind of locks in that ball and socket joint. It's that one, and that particular end we call it the proximal epiphysis. Now let's just remember some of our suffixes and prefixes again. Epi means kind of above type of thing, and so of course this bone is above the diaphysis, and then it's proximal because it's closer to our actual trunk, to our body. It's moving up. In contrast, we see the other side, okay, called the distal epiphysis. And that's because that guy is the one that's moving away from the trunk. It's distal from the trunk. Keep it in mind when you see these 2 ends. Now, the diaphysis, this guy is going to be covered in some very dense fibrous tissue, and we call that tissue the periosteum. It's almost like a sheath that's kind of covering the entire exterior of our long bone, of our diaphysis. And so it's almost like saran wrap kind of around the bone. And also you need to know, inside of your bone you have a cavity. You have a hollowing, and we call this the medullary cavity. It's just a hollow inside shaft. Most of the time it is packed with something. It is usually packed in adults with yellow marrow, something we call yellow marrow. It's consistent of a lot of fat storage for us. If you're talking about infants or very small children, usually what is found in there is some red marrow to help with creating a lot of red blood cells. And so that red marrow will also be found in that medullary cavity. So here's just kind of a nutshell of what we had talked about on the anatomy. We have, again, just to recap, we got in our long bone, we got compact bone and spongy bone tissue. And then if you're talking about the middle shaft area, we're going to talk about the diaphysis. And then we have what we call the epiphysis, different ends. And if you're talking about the one that's closest to you, it's proximal. And if you're talking about the one that's farthest from you, it is distal. And of course, it's covered by this sheath on the outside called the periosteum. And then it has this nice cavity in the inside called the medullary cavity that will hold either yellow marrow or red marrow, depending on the age of whoever the bone belongs to. All right. So that's kind of a macroscopic view of what we just talked about, but let's delve in a little bit deeper, and let's talk about the microscopic view of your bone, the microscopic anatomy. And so let's first just start out, if I were to zoom in really, really, really close, which you can kind of see in the corner over here, if I were to zoom in on my long bone, you would find some bone tissue that is characterized in a very ring shape, and we call this the lamellae. Now the lamellae, okay, in each one of them, they just kind of look like circles, kind of like concentric circles, like you would see like a tree trunk very concentric circles. And inside each of these lamellae, you see like these little pits, almost these little pockets. And we call these guys the lacunae. And they're where our bone cells are actually kind of stored in these pits. They're actually inside of there, so keep that in mind. Looking at our lamellae, you will see kind of a cavity that kind of runs vertically through it. We call this the Haversian canal. Now, the Haversian canal, okay, it's in each one of what we call an osteon. So, if you will, look at my picture, and you will notice that if I were to pull out, a concentric set of circles there, a full set, I guess you could say, it kind of looks like a tree trunk. If I were to just kind of pull one of those whole things out, we call that one kind of set a osteon, okay? And so if I were to look at my osteon and I would look at the very center of it, I'm going to notice that there's a big canal that runs through there. And this canal, like I said, is the Haversian canal. And really, it's not empty. What is actually inside of it are lots of blood vessels, lots of different vessels that will be needed for our bones in order for them to become nourished. So keep that in mind. You need that. Now, connecting these Haversian canals, okay, because we have to create a network of systems. It's almost like pipes in plumbing. What's going to connect these guys together is what we call the Volkmann canals. And they're the ones that are kind of running horizontal. So think a Haversian is running vertically, and then the Volkmann is running horizontal through. All right, so let's talk a little bit about our types of bone cells that we actually have in there. There are 3 types that I want you to be aware of. 2 right now. These first 2 are what we call osteoblasts. Now, osteoblasts are actually what help build up our bones. So in order for our bones to grow and to get bigger, they need to have a mineral framework, a framing of what the bone needs to look like. And our osteoblasts do that. They lay down the necessary minerals needed to kind of create this bone. Now, while simultaneously they are doing it, there's a different type of bone cell called an osteoclast that is shaping our bones or forming them by breaking down different parts of what the osteoblast is building so that we can get like this shaping effect happening. And these guys work in tandem with each other. Osteoblasts are building up while osteoclasts are kind of breaking it down to shape it a certain way. And depending on what you're looking at, which bone, if you're looking at a very mature bone, an adult mature bone, usually we won't say that the cell in there is an osteoblast. We'll usually say it's an osteocyte, which is the actual cell of the bones. It's an osteocyte. A blast is usually when that bone is starting to grow and still forming. But if it's not really, well, we call it usually an osteocyte in there. There are still osteoblasts, of course, in bones that are still not growing, but there are fewer than there are when they're very young and still growing. And these guys, okay, these cells, they need to be nourished. They need to have a hookup to that nourishment that's being supplied by the various blood vessels. And so how this happens is there is a tiny network of little tiny canals all throughout that we call these the caniculi. And the caniculi are what kind of are helping nourish some of those bone cells. They're really tiny, and they'll hook up to the Haversian and the Volkmann, and they'll just kind of feed in that way. So here's kind of an overview, I guess you can say, of my microscopic view of my bones. What you're looking at right now is just one osteon, okay? And if I were to break it down, you'll see in the center we have that Haversian canal. You'll see these concentric rings that kind of create that osteon called the lamellae. You'll also find little pits inside of the lamellae called the lacunae, where those osteocytes are going to just kind of hang out and chill in there, osteoblasts and clasts and various things. And then you have the caniculus, or the caniculi, that kind of connect these pits together with the blood supply in order to nourish these various cells. So let's just talk a little bit about bone growth and how it happens. Bones are continuously growing in length, okay, throughout childhood. You guys know that because many of you are a different height than you were when you were a child. If you're anything like me, well, you're not that much different than you were when you were a child. I didn't seem to grow very, very much. But now when we're looking at bones of embryos, okay, bones of embryos and still inside of us, they don't actually have what we call bone. they have mostly bones that are created out of what we call hyaline cartilage. It's a very hard cartilage. If you actually touch your nose right now, all of that feeling, that hard stuff kind of at the tip of your nose, a lot of people think that's bone. That's not. That's actually a beautiful form of hyaline cartilage in there, and you can see how hard it actually is. The cartilage will gradually be replaced with bone, which is a process in which we call ossification. It just simply means a changing of creating bone. And how this usually happens is at growth plates, or sometimes they're referred to in a common way as growth plates. If you want to get more scientific about it, it's going to be called the epiphyseal plates. And these are going to be layers of cartilage that are being replaced or ossified by bone, okay, in order for us to regrow until adulthood and get to a final length. So I have that here. We'll start out in an embryo, and you can see that kind of clearish white look. That's all that hyaline cartilage. And so it's sufficing as a model, I guess you can say, for the process of ossification about to happen, where we're going to replace it all. And so as you go along and you move into an embryo stage, into a fetus stage, you can see that ossification has actually happened a lot. And you have not as much hyaline cartilage. You actually have some bone, and you're starting to form these medullary cavities. You're starting to kind of grow in length and various things like that. And this will continue all the way up until adulthood, of course, but childhood is where we see the drastic contrast, where you see a lot of bone and very, very little cartilage. You actually only see a little bit of cartilage on the ends called articular cartilage, and you're going to see this forming of this epiphyseal plate, where you will see the bones start growing in length, and that's kind of where you see how those children kind of shot up over the summer. That's because of those epiphyseal plates and that growth that's happening. So you see it here. I kind of zoom in on that epiphyseal plate, and you'll notice that first what forms is a new layer of cartilage, and eventually that cartilage will become ossified, and when it does, that's when you kind of get that new layer of bone, and you'll just continue to kind of grow in length from there. We'll talk about in the next couple of videos, I'll talk a little bit about axial and appendicular skeleton, and I'll talk a little bit about our different joints that we have and various things like that. But for now, here's just a brief overview of kind of our skeletal system.